Evergreen is a pharmaceutical contract manufacturer, and we serve a segment of the industry called radiopharmaceuticals, where we use small amounts of radioactivity in order to produce cancer drugs.
We aim to fill that need in the industry and work with partners who are developing these really interesting and novel radiopharmaceuticals and be able to help them get it, from pre-clinic through to early clinic and all the way to commercialization.
We wanted to achieve a lot of things in this building. We wanted to be high production capacity. We wanted to have an efficient workflow that was suitable for the highest standards of GMP. And we wanted it to be a beautiful building. We wanted employees to really enjoy coming to work here.
Obviously, we're sitting in the office space, which is really important to be able to come to work every day and have a nice place to work. But the main guts of the building are downstairs, below our feet in the manufacturing space. Obviously, that includes a clean room where we do the sterile manufacturing and prep of these materials, but also controlled areas around that to support the manufacturing. So it's storage of starting materials and incoming radioisotope that we use for the radiopharmaceutical.
We had great ideas coming from the Hodis side, from the Bergman side, from the Evergreen side.
Our experience in radiopharmaceutical industry helps us with early calculations to equipment selections, and ultimately that helps us with early procurement design packages and planning the layout for the built infrastructure.
We accept input from the contractor, from Hodis, in terms of efficiencies and how the building should go together. And they accept our suggestions and ideas about how it can be built or how it can be configured.
With my knowledge and their knowledge, we can come up with something that maybe nobody had thought about before or we hadn't thought about before. So all that stuff was great, and just being able to hit the ground running with them and be able to come with them with ideas or issues and not have pushback but have dialogue, that was the best part.
The production areas, locating them and maximizing the footprint, we worked very closely with both Evergreen and Hodis. Kevin Stanton and James Cook worked and had ideas about the relationship of spaces next to one another. We worked to confirm classification of spaces and then flows and the proper separations. And then the footprint and the flow on the site had to be integrated with that.
The tricky part of that from the design side was that it's a relatively small lot in that we had to utilize every inch of space that was available to be able to support all the operations and the things that we needed to do within that space. And we had to do it within the town codes, right? So
the offices face the parking lot. We still have an aesthetically pleasing street-facing side, but we turned the building backwards in order to make it more efficient.
Normally, as architects and as structural engineers, we want a regular structural bay, but it didn't work here. And the decision, working with the contractor, that the economies of having unique structural bays across the building in order to accommodate the functions within the building was an appropriate decision to make because it facilitated those functions in the future. And it was a small premium to pay for dissimilar bay sizes.
It's different in radiopharmaceuticals. If you have a problem that day, you can't deliver the medicine to the patient.
So you have really important processes going on with lots of sensitive equipment. So it's really important to make sure that that process is never interrupted because that could have a quality impact on the product that they're making. So redundancy was really a huge factor in building this facility to make sure if there was any sort of grid interruption that their production would not be interfered with. So having the generator on the roof is unique. And we really came to that solution based off of some of the constraints that we were handed. So this project was very space constrained. Typically you'll have a generator on the ground level, and that just was not an option for this facility.
So we've already done tests on that, and we've seen that everything works the way it's supposed to. And that's really critical for us, because if we're making a batch of drugs for patient use, that's really critical. If we have a power outage, that could really set us back. And if we can avoid that by managing it from a design side and an operation side, then that really saves us a lot of headache.
One thing that is really important to these facilities, radiopharma specifically, is the exhaust air streams, and making sure that since they're dealing with these radioactive materials, it's really important to make sure nothing gets out of these facilities. And it's important in the mechanical system design to account for that. We accomplish this by putting in filtration systems on all the exhaust systems that were connected to manufacturing tools. And these systems are high efficiency gas absorbers.
The interactions due to COVID were mostly virtual, but what that allowed us to do was share screen, present design topics. I was able to fully immerse them into the virtual reality aspect of it, so they can walk around their facility, so they can see with their own virtual eyes, so to speak, what the final product would look like.
Our team members were in Rochester, in Albany, in Philadelphia, and we work across the globe with manufacturers in Italy.
We're absolutely pleased with the facility. It meets all of the goals that we had for it. It has a beautiful, clean, modern design. Most importantly, we've brought customers through and they're really impressed with it. We think this is gonna help us be successful. It's gonna help our company grow. We have a lot of room to grow within this footprint, and we did it in all in 2 years. And so we're really pleased with that.